Network ID. In this video, we are going to see what is network ID and subnetting. The IP address has two parts. One is the network ID and the another one is host ID. The network ID is used to identify the network and the host ID is used to identify the device which are present inside the network. So the network ID is a part of an IP address. So why network ID is very important means the network ID is used by the routers to understand where to send the data. So by using the network ID only, we will able to separate the networks from the each other. Let us consider the example 192.168.1.10 is a IP address and it belongs to class C. We will see what is class C in the next slide. So here the network ID is 192.168.1.0 and the class C contains the 24-bit for the network portion and the 8-bit for the host portion. And the network ID contains a 0 in it. So if the 0 is present means then it is the network ID and it always starts from 0. And here the host ID is the 10 which is the last 8-bit and it is dedicated to the host portion. Classes of IPv4. There are 5 classes in IPv4. The first class is class A. It ranges from 1 to 127. And here it is used for the larger network because by using this class A, we will able to host nearly 60 million computers per network only. Class B ranges from 128 to 191 and it is used for medium sized network, and by using this class we will able to launch nearly 65,000 computers per network. Class C ranges from 192 to 223 and it is used for the smaller network usage, and by using this class we will able to host 254 computers per network. And the class D is used for multicast and it ranges from 224 to 239. And finally, the class E is not used in the public network because it is used for the research or experimental purpose. And it ranges from 240 to 255. And we use first 3 classes, class A, class B and class C only, and all these classes have the private IPs. And each class has two parts. One is the network portion and another one is host portion. The class A contain the 8-bit for network portion and 24-bit for the host portion. Class B contain the 16-bit for the network portion and 16-bit for the host portion. Class C contain the 24-bit for network portion and 8-bit for the host portion. And the next one is subnetting. What is subnetting is, it is the process of dividing one larger network into the smaller network. Why the subnetting is done means, as I said earlier, that by using the class C, I can able to host 254 computers per network only. If I use this class and I host only 40 to 50 computers only, then the remaining IP address will be a wastage. To reduce this wastage of IP address, the subnetting is required. So by doing the subnetting, we will able to reduce the network conjunctions and each subnets will isolate from the each other. So if one subnet failure means it does not affect the other subnets also. And because of all this purpose, we did the subnetting. And the next one is subnet mask. What does subnet mask means? It will help us to decide how many bits are allocated for the network and host. If we take this IP address 254.0.0. It is IP address, /8 indicates that network portion. So the 8 bits are allocated for network. And the next one is CIDR notation. What does CIDR notation means? It is a classless inter-domain routing, which means by using this, we will write the IP address along with the network bits. So by using this, we will able to identify how many bits are allocated to the network. Here the /24 indicates that the 24 bits are allocated for the network. So it is also similar to the subnet mask. How we can do the subnetting means we can use the formula 2 power n. And here the n denotes the number of borrowed bits. Let us consider the IP address 192.168.1.0/24. Imagine I am going to deploy the one application. For that I need 4 subnets, and each subnet is allocated to the different departments. So this IP address belongs to class C and it has 24 bit for the network. And I want 4 subnet. So take the formula 2 power n. Which number will be placed in n? It will give the 4 means 2 power 2 will give 4. So the here 2 will be placed in the power. So which means I need to borrow the 2 bits. If I borrow 2 bits means then 24 becomes 26, and the 26 bits is allocated for the network portion. Initially the class C have only the 24 bits and I borrow the 2 bit from the host portion. Totally the network bits are 26 allocated. And I take the last 8 bit and I do the possibilities for the 2 bits only, because that the 2 bits borrowed for the network portion. So the possibilities are 0, 0, 0, 1, 1, 0, 1, 1. And I do the binary to decimal conversion, and I start from the rightmost end to the place values, and finally I need to consider all the positive values in the bits. 0, 0, 0 means here there is no positive value. So the IP address is 192.168.1.0/26. It is allocated for the first subnet. And the next possibility contain the positive value which is present in the 2 power 6, and it is 264. So the IP address is 192.168.1.64/26, which is allocated for the second subnet. And the next possibility is 1, 0. Here the positive value is present in 2 power 7, which is 128. So the IP address is 192.168.1.128/26, which is allocated for the third subnet. And that last possibility is 1, 1. Here there are 2 positive values, so add 128 plus 64, so we will get 192. So the IP address is 192.168.1.192/26, which is allocated for the fourth subnet. So the each subnet will have the IP address. So from that IP address we will able to host the devices, but before subnetting there is a huge loss of IP address. But here compared to that, here is there also a wastage of IP address, but compared to that here it is less wastage.